Hi, my name is Caitlin Nias and I'm here at the Dorothy Pico Nature Center. Today I will be teaching you a science experiment and we'll be making solar oven cookers and s'mores within them.
The first thing you're going to do is to measure 1 inch from the inside, and we're going to mark that all the way around the box. Okay, once I have the 1 inch marked all the way across the box, I'm going to take my ruler to make sure I have a straight line, and I'm going to line up those points, and I'm just going to mark it all the way around the box. Alright, you'll see here I poked a hole into my box on the inside of this line, and so now I'm going to use that to cut along the inside of this line. And I'm going to leave one edge attached because this is going to be a flap that I use to pull up to create the inside of my solar oven. I'm going to fold it up right there. So you can kind of see it looks like that if I put it on its side. So it just kind of flaps up, and that is our next step. Alright, the next step is you actually want to increase the amount of sunlight that the solar oven will absorb. So you're going to use some black paper, or if you have paint and you would rather paint the inside of your box, you can do that as well. I'm going to use black paper, or if you have black markers, that may work as well. This is just an easy way to use. I'm going to cut out the black paper, and I'm going to place it in the bottom of my box so that I have that dark surface to attract more sunlight. I'm going to open up the side and slide that into the bottom. And I just measured how big I wanted it to be based off of the box size, so I traced that around on the paper. If I wanted to, I could also do the insides here on the side of the box to also increase the heat. I'm going to maybe try to put reflective material there. The most readily available reflective material is aluminum foil, so that's what we're going to use to line the reflective panel on my solar oven cooker. So now I have my sheet. I am going to put it up against this part of my box and wrap it on. Because I want this to reflect as much light as possible down onto my box. So, I've already done the other two sides, but I will let you see. I am taking some of this leftover aluminum foil, and I'm cutting it to the size of the inside of the box, and I'm using that to line the inside. Now that I have all of my pieces cut, I'm going to pause and take a second to glue everything down into place, including this top piece. The next step in this is to create the cover for the top using plastic cling wrap, and that is going to be able to keep the heat within it. So we want a clear substance that will allow the light to go through and capture it, but it's going to seal it inside the box and make sure that it stays nice and warm. That's the convection part of the solar oven. And I am going to be using tape to attach this. now that I have the second sheet attached to the inside, I now have a finished conventional solar cooker oven. So if I wanted to, I'm going to put some s'more stuff and I'm going to slide it right in this inside here, and it will slowly heat it up and melt the chocolate and the marshmallow. And there we go. Close up, back up the lid, and there we go.
There are three main design styles of solar cookers. So the first design style is called a parabolic cooker, and that can get up to 400 degrees Fahrenheit, and it uses curved reflectors to pinpoint up to the bottom of a pot. It is the largest solar cooker. It can get up to several feet across. It is also the most effective solar cooker, as it can get up to 400 degrees Fahrenheit. So it is the hottest cooker, and it can cook meat and several other things. The second kind of solar oven cooker is the solar box oven. They can be large and heavy as well, and buying one can be extremely expensive. If you look up online on Amazon or somewhere where you could find one or buy one, they can get up to $400 or more. They're extremely expensive. It is an enclosed box that heats up and seals in the heat. So the inside of the box is black, as that absorbs the most light energy, and has some form of glass or clear plastic on top to allow the light in, but to preserve the heat. The final way of a solar oven cooker would be a panel cookers, and they are the most basic form of solar cooker. It combines elements of a box cooker and a parabolic cooker. They use curved reflective sheets, much like a parabolic cooker, without some of the weight, because they use a pot or a plastic bag that they set in the middle of the cooker to retain heat. So right in front of me are the panel cookers. First, I'm going to explain some of the science of how these cookers work. So you'll notice we covered the top in the aluminum foil. Most solar cookers have some kind of reflective surface. Ours are made of aluminum foil, so aluminum is a common feature in many solar cookers, as well as other metallic objects such as steel or other shiny metals. The insides, the bottom, is black. That is because black absorbs the most amount of light, so it collects. Light has every color that is visible to you and me. And so black collects all of that light and all of the colors of light, and that's what makes it warmer than the other colors. Because you see colors because it reflects that portion of light. So the tape is blue because it reflects blue back at you. It does not absorb that color. Black absorbs all, which is why it's the darkest, because you see all of the pigments. So as it collects that, it gains more energy and more heat. And then the reflective surface adds more sunlight and more heat, because sunlight has an internal energy. So as it interacts with matter like you or me, or even this box, it transmits into heat energy. And so as it hits those molecules and transforms into heat energy, the molecules start moving more quickly, and then they collide and pass the energy to and from each other. And when they collide, that creates friction, which causes more heat. And friction you can feel like if you rub your hands together and they get warmer, that's an example of friction. So as the molecules hit each other, they're warming up the box even more. The plastic that covers the top is meant to be an insulation so that the heat cannot escape. So even though the sunlight can come in, the double layer of plastic is an insulation to ensure that that warm air and molecules stay inside the box. you for joining me today for our Science Outdoors. I hope you enjoy your s'more. Have a great day and like and subscribe.